Next one. Draw the electron dot structures of ethanoic acid, H2s, propanone and fluorine. So there are 4 compounds. We need to draw the electron dot structures. It's very easy. You need to know how to write the chemical formula, how to write the structural formula. Then we can draw the electron dot structure. First we can start with ethanoic acid. Ethanoic acid, there are 2 carbon. One carbon is with COOH. Oic acid is carboxylic acid, right? So this one carbon is present in this functional group COOH. So C and COOH, and there is a single bond. Now we can fill hydrogen, right? Here for this carbon there are 3 hydrogen atoms, so it is CH3COOH. Now we are going to expand this CH3COOH, expanded form. C is forming 3 single bond with hydrogen, 1 single bond with the other carbon, and this COOH is also having an expanded form. We already discussed it. You need to learn that. We are going to draw it again. This is the expanded form of CH3COOH. CH3 and COOH. Now we are going to draw the structure, the electron dot structure. You need to learn one thing. Single bond means there is one pair of electron. Double bond means there are 2 pairs of electron. That you need to learn. So here there are single bonds and there are double bonds. You need to learn what is the difference between this single bond and double bond. Here you can see the structure, expanded form. From this expanded form we are going to draw the electron dot structure. There are 2 carbon atoms, right? First we are starting with this carbon atom CH3. See, in CH3 there is a carbon atom. We are starting with that. C, hydrogen, hydrogen, hydrogen. All bonds are single bond. Single bond means there is a pair of electron. Pair means 2 electrons. One electron is from carbon, other electron is from hydrogen. So we are marking that. The yellow electron is from carbon, red electron is from hydrogen, and all bonds we marked here. Here now CH3 is over. Now there is a bond between C and C. Here you can see that there is a bond between C and C. That is a single bond. So we are drawing that. The next carbon is here. This is the next carbon, and in between there is a single bond. The bond is between carbon and carbon, so 2 yellow electrons. Now here from C there is a double bond to the O. We are going to draw O here. This is O and it is double bond. There are 4 electrons because it is a double bond. 4 electron, 2 pairs of electron, right? So 4 electron, the white electron is of oxygen, yellow is of carbon. Now this section is over. Now the OH section. OH means O single bond H. That also we are going to draw here. There is a bond, single bond. 1 electron is from carbon, 1 electron is of oxygen. Then there is a single bond. 1 electron is of hydrogen, 1 electron is of oxygen H. We are just copying this diagram in the form of dot structure. Just exactly the same. Oxygen is having 6 electrons in the outermost shell. So we need to mark all the electrons in this dot structure. Carbon is having 4 electrons. We already marked electrons around the carbon. Hydrogen is having only 1 electron. We already marked it. But oxygen is having 6 electrons. For this oxygen, 2 electrons are participated in bond formation. Remaining electrons are 4. For this oxygen, 2 electrons are participated in bond formation. Remaining electrons are 4. So for both oxygen we are giving 4 electrons again. This is the dot structure of electron dot structure of ethanoic acid. Next one. H2s Hydrogen Sulfide. There are 2 hydrogen, 1 sulfur, right? Sulfur, the atomic number of sulfur is 16. The configuration is 286. Outermost shell is having 6 electrons. We need to consider the last shell, outermost shell. There are 6 electrons. We are going to mark it. The atomic number of hydrogen is 1. There are 2 hydrogen. Atomic number of hydrogen is 1. Now we are going to draw the structure. Sulfur, hydrogen, hydrogen, right? This is a structure. We are going to draw the dot structure. 2 hydrogen, 1 sulfur. First we are marking sulfur here. The electron of sulfur and hydrogen. There are 2 hydrogen, right? Hydrogen and hydrogen. Between these 2 atoms, between sulfur and hydrogen, there is a single bond. So we are marking that single bond, right? Only 1 bond, 2 electron. 1 electron is of sulfur, 1 electron is of hydrogen. So the circle is electrons of sulfur and the cross mark is electrons of hydrogen, right? And here also there is one more bond here. that is also single bond, so 2 electron, 1 pair of electron. How many electrons are there in the valence shell of sulfur? There are 6 electrons. 2 electrons already participated in chemical reaction, already participated in bond formation. Now remaining electrons are 4. So we are marking that 4 electron. This is the electron dot structure of H2s. Next one, propanone. Propanone is also very easy. First you need to draw the structure of propanone. There are 3 carbon atom, that is propanone, right? 3 carbon atom and one is with CO. CO is the functional group here. So it is C, CO, C. Single bond. Now we are filling hydrogen, CH3, CH3. The same structure, this is the structure. We are going to convert this structure into electron dot structure. So this is our expanded form. We are just expanding it. C, 3 hydrogen, CO, C double bond O, and CH3, C, 3 hydrogen. This expanded form we are going to convert into dot structure. This is our expanded form, and here we are going to draw the dot structure. First we are taking carbon. Around the carbon, how many hydrogen atoms are there? There are 3 hydrogen atoms, 1, 2, 3, and all bonds are single bond. 1, 2, 3, 3 single bonds, and there is a bond between C and C here. Here you can see that there is a bond between C and C, right? So next C, and there is a single bond, 2 electrons, yellow electron, the same electron. After that there is a double bond. Here you can see that there is a double bond. For the double bond with oxygen, right? So we are drawing oxygen here with double bond. Double bond means there should be 4 electrons, 2 pairs of electron, 2 electrons from carbon, 2 electrons from oxygen. Now again there is a single bond. Here you can see that there is a single bond. We are drawing that single bond here with carbon, right? C with single bond. Clear? Next there are 3 hydrogen. 1, 2, 3. 3 hydrogen with single bonds. This is the structure of propanone. The last step is filling electrons. For oxygen there are 6 electrons in the outermost shell. Only 2 electrons we have used here. We are filling the remaining 4 electrons. Now this is the structure of propanone, electron dot structure of propanone. Next one, fluorine, F2. The atomic number of fluorine is 9. The configuration will be 2, 7, right? Fluorine 9, 2, 7, fluorine 9, 2, 7. These atoms are going to form a bond. It will be single bond because this fluorine is having a requirement of 1 electron. This fluorine is also having a requirement of 1 electron. They are going to form a single bond. They are going to share 1 electron, total 2 electrons. They are going to share these 2 electrons. 2 electrons means single bond. F, single bond, F. Now we are going to draw the electron dot structure. This is very easy compared to other diagrams. Here we can see that F, single bond, F, and F, there is a single bond, right? Single bond means there are 2 electrons. We are marking the 2 electrons here. Same electron because the 2 electrons are from fluorine. Now the next step is filling remaining electron. The total number of electrons in the outermost shell of fluorine is 7, right? Only 1 electron of this fluorine, 1 electron of this fluorine has been used. The remaining electrons are 6. This is the dot structure of fluorine.